Solving systems with elimination, again, another strategy. It has its benefits, it has its downsides. We're going to take a look at a couple examples here. This is what you're looking for. These are the steps. You should write these down, and this is what you're sort of referring to as we do the example problems. All right, so example 1, you see example 1 here is set up perfectly for us because we already have opposites, positive 4 and negative 4. So we don't have to do any work to set this equation up. What we're going to do is add these two equations together. Because when we add a positive 4 and a negative 4, we make a 0. So there's no more x's in the problem. And then negative 2y and positive 8y makes 6y. Negative 12 plus negative 24 makes negative 36. And you notice that as far as steps are concerned, elimination is a lot shorter than both graphing and substitution if it's set up well. So we divide by 6, and we already have y by itself. Y is negative 6. Okay? Still have to go back and plug in for x. So I'm going to take that negative 6 for y. I'm going to choose either equation, doesn't matter which one, and I'm going to plug negative 6 in to solve for x. Go ahead and do that. So when I solve that, I end up getting x equaling 6. So follow my steps here, minus 12s, divide by negative 4s, so forth. And don't forget, the final answer here must always be written as a coordinate. So that is 6, comma, negative 6. And what does that represent? The intersection point if I were to graph them. Now, the second example here is a little more involved. Notice I don't have opposites here. 5 plus 3 is 8. Negative 5 and negative 2 is negative 7. So I'm no good right now, okay? I need to get opposites. So there's a couple ways to go about doing that. So I'm going to look at the 3 and the 5, and I know that 3 times 5 is 15. So I'm looking for almost the LCM here. I mean, it is the LCM of those two numbers. Okay, so in order to get opposites here, I'm going to have to multiply this top equation by 5. And I'm going to have to multiply the bottom equation by negative 3. So let's see what happens when I do that. And just the recognition here is the hardest part. Everybody can multiply. 5 times 3 is 15x. So we distribute the 5 to all the terms, and you'll see what happens here as we do this. The negative 3 distributed in the bottom equation gives us the negative 15x that we want, because now we have opposites, positive 15, negative 15. Continue to distribute that 3 everywhere in that second equation. Now when we add the equations together, we get the action that we wanted, which is these two opposites make a giant 0. Add the rest of these together, I get 5y equaling negative 20. I solve for y for negative 4. Okay. Don't forget that that's only the first half of it. It's the harder half, but it's only the first half. I'm going to plug that negative 4 back into either equation that I want. So 3x minus 2 negative 4 equals 2. So I'm replacing the y with the negative 4 that we found for it. I'm going to then solve that equation, which this should be the part that everyone can do. And I get negative 2 for x. And one last thing, our answers are always written as coordinates. So your final answer should be the coordinate, and don't forget that that is the point of intersection if I were to graph these two lines. One last example. This example will be a special case. So let's take a look at this. Similar idea here. The 2x and the negative 5y, they're not opposites. The 8, the negative 20, they're not opposites. So right now, as it stands, nothing's going to cancel out. Okay? And again, we're going to look for the LCM. Now, I'm saying let's choose 2 and 5, right, because they're smaller numbers than 8 and 20. So, you know, if you don't want to deal with really large numbers, we'll cancel out the x's. Now, they're already opposites, so all I need to do is multiply by 5 and 2 so I can find the LCM. So when I distribute, 5 times 2 is 10, times 8 is 40, times 6 is 30. So I have 10x, 40y equaling 30. Down here, I'll get the negative 10x that I want. All right, and I'm going to get a negative 40y, and I'm going to get a negative 30. So here's where this is what makes this situation unique, because when I look at this, 10 and negative 10 make a giant 0. 40 and negative 40 make a giant 0. 30 and negative 30 make a giant 0. So it doesn't mean I have nothing left. What I have is 0 equaling 0. So remember from the last video in substitution, when everything cancels out and there's no more variables left, we ask ourselves the question, is this a true statement? So does 0 equal 0? And if it does, which it does in this case, then all solutions would be our answer, or infinite solutions. Because these would be the same exact line. So you'd graph one line, you graph the second line right over top of it.